LeetCode Problem 239, Sliding Window Maximum. So this problem gives us an array of integers, and there is a sliding window of size k. And basically what we have to do is to return the maximum number in that window for return it as an array, right? So something like this. This is a great example. Right, so this window, the maximum will be 3. So 3 is the max. Same thing for this one. 3 is the max. Same thing for this one. 5 is the max, and so on until we get the answer of 3, 3, 5, 5, 6, 7. Okay, so my approach to this problem is to use a DQ, and this DQ is basically for storing the largest number in every window in descending order, and I'll explain why in a bit. But let's say I have a DQ here, and I'll just run through how my code will run, right? So I'm going to use this example. So better visualization. Okay, so the first things first, I initialize the size of the nums array, and I have a empty vector that I prepared the size for. So basically, if you use size, which in this case would be, let me count, 1, 2, 3, 4, 5, 6, 7, 8, 8. 8 minus, okay, so 8 minus 3 plus 1. This will basically give us, this is 5 and 6. Give us 6, which is the number of answers, right? 1, 2, 3, 4, 5, 6. Yeah, basically it gives us the size of the output that we need. And the reason why I do this instead of using pushback, which I also can do, is this will improve the performance slightly, right? Because if I use pushback, then the vector has to keep reconstructing. Something small, but you can definitely use pushback for this, and it'll be less. Then you don't need this. You can just do press dot pushback and then DQ front like this. Okay, the same thing, but I prefer to do it this way because of the slight performance improvement. And then we have the DQ, which I mentioned that we will store the numbers, the biggest numbers, in descending order. Okay, so in the for loop, I have an I. Let me initialize I. So I will start from the beginning and you iterate it through till the end of the array. So at the first iteration, nothing happens. This to while loop does not run because the DQ is empty, and I'll just push back I, right? So I now is 1. Okay, this part is basically checking whether I, which is now 0, is more or equal than 2, which is not, right? That means I has not reached the right side of the window yet. Okay, the next part, then we continue on, right? And now that our DQ is not empty, we are checking whether or not this number, sorry, I'm pushing back the index, my bad. We're checking whether or not this index is less than I minus k plus 1. Okay, so what is I minus k plus 1? So remember I is now 1, so 1 minus 3 plus 1, this will basically give us negative 4 and then negative 3, right? So is this lesser than negative 3? Yes, right, actually. Is this lesser than negative 3? 0 lesser than negative 3? No, right? So we don't do anything, and we don't do anything, and we look at the next option. So if this is this number, we're using the index at the back of the DQ, but for this case we only have one, so this is what we only do. And then we are comparing it against our current number, which is 3, right? So is 1 less than 3? And in this case it is, right? So in order to maintain a DQ where the biggest number is stored from where the number is stored from in descending order, we have to pop this index and then push the new index, which is 1. And this one basically holds the number 3, which is currently our biggest number, right? Okay, after that, after we push back, then we check again. And since I is now 1 and it's still not more than equal to 2, so we don't need to put anything inside our result array. Then we check again. Now is 1 lesser or equal to I. Okay, since I incremented, so is 1 lesser than -2? It is, right? So we don't need to do anything. Actually, it is not. 1 is more than -2, right? So we do not need to do anything here. Okay, after that we're comparing numbers again, number from the back, and checking whether or not this 3 is lesser than our current number, which is -1. Right? This is -1. And since it is not, right, since 3 is still bigger, we don't need to do anything. And we push back I, right? So push back I. So this tool is storing our -1. Okay, after we push back, since I is now 2, that means that we have reached a valid window. So our result, this will give us 0 because 2 minus 3 plus 1, this is -1, and then plus 1 equals 0. So our result at index 0 will be the nums at the front, which is, in this case, the index is 1. This will be 1, and in 1 it is 3, right? So our result is 3 for the first index. After that, we go into this while loop again, increment our I first. Okay, then we go into this while loop again and check whether or not our 1 is lesser than 3 minus 3 plus 1, which in this case will be 1. So it is not, so we don't have to do anything. And this while loop, we have to check whether or not the number at the back, right, which in this case is 2. Hey, sorry, this case is -1, right? Value is -1. Is it less than -3? So it's not, right? Since it's not, then we don't have to do anything, and we push back -3. Okay, that means for our next window, our current largest is still 3. Okay, so now it is like this. Increment I, and then we check on this while loop. Is the front is 1 less than 4 minus 3 plus 1? I'm going to simplify this to -2. And then since 1 is now less than 2, that means we have to remove this, right? So what this means is that this 3 has now left our window, right? That means the current maximum of these two number is -1, right? That's why we have to sort the DQ in descending order. Okay, then we check on our while loop. Is this -3 lesser than nums I. Nums I is now 5, right? 4, right? Nums I is now 5. It is, right? This -3 is less than 3, so I have to pop back -3. So we remove this, and now we're checking whether or not -1 is lesser than 5. And it is, it still is, so we say remove, right? Remember what we removed? We removed -1 and -3 in order to make space for the 5. Right? So that means our DQ is still sorted in descending order. Right? If we didn't remove it, then we'll have a negative, then we'll have a 5, like, and this is basically not sorted anymore. So that's why we have to remove it. Okay. After that, we check again. Right? Since it is this window now, so we know that the front, since it's only one number, so the value is 5. So increment to 5, and then our I will increment to now look at this tree. Again, we look at it, we look at the index to see whether or not we have left the window. So is 4 less than 5 minus 3 plus 1? So 4 is more than 3, right? So we don't need to do anything. And next one, we have to check again whether or not 5 is lesser than 3. And it's not, so we don't have to do anything. That means even if we push back, this DQ is still sorted. Right? Then when we do this again, okay, the answer is 5. So we push, so we add in 5 again, and then we repeat the same step. Right? Is 4 lesser than? Is 4 lesser than? This needs to be incremented 6. Is 4 lesser than 6 minus 3 plus 1? This will be 2. This will be 4. And since 4, since this evaluates to false, right? Since 4 is not less than 4, yeah. So we don't need to do anything. And here we have to check. Wait, let me make sure. This 4 lesser than I is 6. 3, 4, 5, 6. 6 minus 3 plus 1. 3 plus 1. Okay. So our second while loop, we check again whether the number at the back, whether or not 3 is lesser than 6. And in this case it is. Right, it is lesser than 6, so we have to pop back. We have to pop this back. And now we have to check whether or not 5 is lesser than 6, and it is, so we still have to pop this back. And then only put in 6. Okay. And then we check the answer. For this current window, it's 6. Okay, same thing. We try out now whether it's inside our window. It is, so we don't need to do anything. And here we're checking whether or not 6 is lesser than 7. Right, this is 7. And since it is, we have to pop this back, push in 7, and then check the answer again, and put back 7. After that, our I will increment to 8, and basically get out of this. Basically has finished iterating through the entire list. And when that happens, we return the result, which is this, right? Result equals 3, 3, 5, 5, 6, 7. And if you look at the output for the example given, it is the same. Okay, that's all I have to show. Thanks.